Good afternoon, everybody. We're going to jump in here with the session today and talk a little bit about how to build a basic template using CloudFormation and then deploy that template inside an AWS account. So a couple public service announcements here before we get started. CloudFormation itself, the service is free. The resources that you deploy with it are not. So you would always want to make sure that you understand what it is that you're creating. You know, instance sizes, number of instances, all those things are gonna affect your bill. So just keep that in mind when you are learning about CloudFormation. While the service itself is free, the resources are not. And that leads to my second sort of PSA is really probably a great place to start with CloudFormation is how do you create a budget, right? I know a budget isn't a perfect solution to this, but at least it would provide you with a notification to let you know that obviously something isn't quite right. And my suggestion would be create a simple budget using CloudFormation, have that budget fire on something very low, maybe just $10 if it's in your personal account. That way you get no surprises at the end of the month. This would be a project after you've seen the slides today that I might suggest is a good starting place. Okay, so with those couple public services announcements out of the way, let's get into the actual content. Hey Kevin, welcome. This is really meant to be an introductory lesson in CloudFormation, so we're not going to go super deep into a lot of more complex topics. The first thing you need to know are a couple basic definitions, and the first one is a template. What is it, and why do we care? Essentially, a template is nothing more than a text file, right? You can decide what type of text file you want to create, whether you're going to worry about wiggly brackets in JSON or tabs and spaces in YAML. That's completely up to you. The one piece of advice that I would give you is, regardless of the format that you want to use, find yourself an editor that has a great linter for either JSON or YAML. It's probably one of the easiest things that you can do starting out to make sure that you're not spending your time with syntax errors. For Kevin, who is here, he knows that syntax errors aren't necessarily the biggest problem. At least in my world, they're spelling mistakes. Obviously, an editor is not going to help you with that, but find a good editor. I use PyCharm because we write a lot of Python code, Lambda functions, and things like that. So rather than having multiple editors, I just used that. So whatever works for you, okay? The other thing to keep in mind is we're going to look at a really basic example of a template. And a template can be made up of a lot of different parts or components, but there's only one part that's actually required. And that's the resources section, which we're going to talk about here in a little bit more detail. Once you've created the template, right, this text file that essentially describes the resources that you want to create in AWS and the configuration of those resources, you run them through the CloudFormation engine, and what comes out the other side is a stack. We'll talk about a stack here in a second. The analogy that I like to use with this is a baking analogy. Essentially, the way that I think about it is a template is like ingredients, right? Let's say you're baking a cake. A cake has flour, I don't know, oil, and eggs in it, right? And you combine those ingredients in different measures, right? Certain, 2 cups of flour to 1 cup of this or whatever it is. And that is really your template. It's the ingredient list and the makeup of those ingredients, okay? When you're making a cake, you got to combine all those ingredients together. I don't know if it's a perfect analogy, but it always works with me. The template runs through the CloudFormation engine, the CloudFormation service. In my brain, the CloudFormation service is like the blender, right? We're going to blend everything together, and then the outcome at some point is the stack, which is our finished cake, right? That's an analogy that's always made sense to me, so I like to share that one. So template, text file, essentially. And as I mentioned, the stack is the outcome of that template being processed by the CloudFormation service. And it really is nothing more than a collection of resources that you want to manage together. Okay. What you'll find is that a deployment, generally, the way that I would approach this is a single deployment. Let's say you've got, you want to build a web-based solution. So you've got a load balancer, some web servers in an auto-scaling group. Behind that, you've got an RDS database, right? Just a typical multi-tiered architecture. You could, in theory, create a single stack, right, which is made up of a single template that describes all of that, right? And I've left out some components. We need a network, we need security groups, we need routing, all that stuff. You could build that all into a single stack and deploy it, and it will work. There's nothing wrong with that. The challenge, though, that you have is that when you're starting out, actually, I shouldn't say when you're starting out. We've been writing templates for a really long time, and I can speak from experience that large templates, right? If I take that entire description of a service and jam it into one template, therefore one stack, those templates become challenging to manage. We'll talk a little bit about this later on, but I'm thinking about troubleshooting and maintaining those templates over time. Normally what we would say is that you would take that example of a web application, right? Load balancer, EC2 instances, and databases, and break it down into multiple stacks, therefore multiple templates. During the stack creation process, you essentially create a stack, template gets run through the engine, now you have a collection of resources. Once that stack has been created, you can then run other operations on it. You can update a stack, which would modify the resources within that stack. And then let's say we're done with this web server or this web application, we could delete a stack, which would, by default, we can override this. We're going to talk about it a little later. You could essentially just delete all the resources. Okay. The other nice thing about operations that are performed on a stack is that by default, CloudFormation, if there's a problem, will always roll back to the previous known working state. So if I have a stack already, let's say I've got a load balancer stack, and I need to make a configuration change to that. So I go into the template that I have that describes that configuration, and I make a change to whatever it is. Maybe I'm going to change the target group or something like that. And I then run it through the CloudFormation engine. If during that stack update operation, CloudFormation is not able to complete that operation successfully, in my case, probably because of a spelling error, what will happen is the default operation is to roll back, right? So it'll go back to the previous known working state, and then you could look in the CloudFormation console, or you could run a command on the CLI and be able to look at the error message that came back from CloudFormation. Why did this not happen? The only time I would suggest that you override the default operation of rollback is potentially on your first create. And this isn't really a big deal, but I'll tell you kind of why I suggest that. Quite often, even if you take the idea of multiple stacks, so you break that infrastructure into multiple components, some of those stacks may actually take quite a while to deploy, right? Depending on the configuration and what is in that stack. What I found is that, I might run a create operation and wander away and grab a coffee. And the default operation is to roll back. That includes on a create operation. It's a silly little thing, but it's just the way that I like to work, is I find it more challenging to scroll through a bunch of CloudFormation output in the event that original stack creation doesn't work properly, looking for an error, right? Again, especially if you have a very large stack definition. What I might do is I might override that rollback on failure on the very first create operation. Because then what will happen is, let's say it's going along, it's creating, we'll use the load balancer as the example again. It's creating that load balancer, no problem, no problem, no problem. It hits something. And what would happen in the default operation is CloudFormation stops, throws the error, and then rolls back, which in that first create means it's going to delete your stack. Okay. If you override that default rollback operation, then what will happen is it'll just fail and stop. It's a silly little thing, I know, but it gives you the ability to, when you come back to your desk, you got your coffee in hand, you can have that crap moment, but there's the error message right there. And I just find it simpler to troubleshoot. Okay. So just remember, a stack is a collection of resources that you want to manage as a logical grouping. That's it. Okay. It's the outcome of running a template through the CloudFormation engine. So those are the two basic pieces of building out a really simple template. We're going to talk about a number of other really important features of CloudFormation, and I thought that it would be best to have just a concept slide here, and two things that you're going to use all the time are intrinsic functions and pseudo parameters. So let's just really quickly talk about what those are. Intrinsic functions are built-in functions in CloudFormation that allow you to build your templates more easily. Okay? It allows you to introduce flexibility. It allows you to then create a template which you could use across multiple environments or potentially across multiple accounts. As I mentioned at the beginning, this is really kind of like a high-level 101 intro. So we're not going to get into all of the different intrinsic functions here, but we are going to write a few really simple templates to just demonstrate some of these concepts. And you're going to see things like a substitute function. You're going to see a reference function. There are two ways that you can refer to an intrinsic function. So you can see in my example here, we have fn 2: sub. So that's function, the substitute function. So that's, I think they call that long form or the default way to use an intrinsic function. But they also have a short form, which is just exclamation and then whatever the function is, right? So in my case, sub. The other really important part of a template are what are called pseudo parameters. We're going to talk about parameters here in a second, but a pseudo parameter is, again, a built-in parameter that is defined as part of the CloudFormation service. The easy way to know if you're looking at a pseudo parameter is they start with AWS, always prefix with AWS, : : So in this example, if I had this in my template and then I run the template through the CloudFormation engine, what is going to happen is when it's creating that stack, it's going to essentially replace that parameter with, in this example, the 12-digit account ID. And there are tons of different pseudo parameters that exist. So account ID, we've got region information. You can even have things like no value where you want to pass in just a null string. Lots of different things here. When I think the biggest challenge that people have when they first start writing templates is, it's just part of the learning process, is that instead of using these built-in features, both intrinsic functions and pseudo parameters, people tend to hard code things in their templates, right? You write in the 12-digit account ID for a parameter that you're setting up, or a property, that you're setting up. You hard code in an availability zone or a region, which is, it works. It'll do what you expect it to do. The challenge, though, the challenge with that is that the moment you hard code a region, a 12-digit account ID, if you took that template and tried to run it in a different region, in a different account, it may not work. In all likelihood, it's not going to work the way you'd expect it to. So what you've done now is you've created a template, but that template is locked to a specific region, a specific availability zone, a specific account, or any combination of those. So it's a challenge when you first start writing these. What you should be doing is always thinking to yourself as you're building out these templates, how do I make sure that this template can be run in multiple accounts across multiple regions? The easiest way to do that is with intrinsic functions and pseudo parameters. So we'll have a look at those as well, a couple of examples here. All right, so that's kind of some terminology, some basic concepts out of the way. Let's actually look at what makes up a basic template. And we're not going to go into details here on every possibility. We're going to keep this high level and just talk about the things that I would commonly see in really basic templates. I've mentioned parameters a couple times already. I like to think of these just as input variables. You can set up parameters that allow more flexibility in your templates, right? And a really simple example is, let's say you're building out an EC2 instance and you want to be able to allow multiple instance types and sizes to be used for that EC2 instance while that CloudFormation stack is being created. That's a great example of where you would use a parameter. Okay? You can set a default value for a parameter. I can override that default parameter either through the CLI, if you're using like AWS CloudFormation deploy commands, or through the management console. Okay? The way that you refer to parameters in the rest of the template is to use an intrinsic function, and this is where the ref intrinsic function comes in. Okay? Now, with a parameter, you can have really simple parameters, a string. So another great example of that is you want to tag your resources. So tagging is really nothing more than a key value pair that provides additional information about resources that you're deploying. So one that we would commonly use is an environment tag. Is this for production? Is it development? Is it something else? Okay, so that would be an example of a very simple string type, right? It's prod, it's dev, it's test. Easy. You can create Boolean statements. You can create numeric types. Amazon also provides us with a lot of different built-in types, and these are really important because the other thing that I think when you're first starting to write templates is that people forget about is that you may not be the person that is running that template. Ideally, you probably don't want to be, right? You get a reference architecture, you interpret that reference architecture, you define the templates, and then you pass them off to various people to run, right? It could be the owner of the product that is going and running these. You may actually, we're going to talk a little bit about template strategy here at the end of the session today. You may actually have multiple teams that are responsible for deploying these templates. Maybe the security team does all of the security group work and the knackles and things like that. And then the dev folks are responsible for the deployment of the databases, the load balancers, all those things. So these built-in parameter types, the way that I like to think about it is it increases the likelihood of that template being successfully deployed by somebody other than the author of that template. Okay? As the author, I know what I'm expecting something to be in a template, right? But once I give that to somebody else, their interpretation of that could be significantly different. So these built-in types help you build out, I said faster here, but maybe a better way to think about this is more reliable templates. Yes, they help you build faster, but I think they increase the likelihood of that template being deployed successfully by somebody other than yourself. And I'm going to show you a couple of these here in a second. The other thing that I just want to point out about these different components that make up a template is all of them but one are optional. Okay? Parameters are optional. You don't need to include them. I think you're shortchanging or making your life more challenging by not using parameters, but they're not required. Okay? Hey, Payman, welcome. So what I'm going to do now is I want to shift over and we're going to build out a really simple template with some parameters. Okay? So let's see if this works. You can see I have cheated a little bit. I'll show you this now. We've got a VPC template built out, and you can see some really simple examples in here about parameters. So I've got this is the ID of that parameter. If I wanted to refer to this parameter later on, I could use the ref intrinsic function and say refer to whatever the value is for the environment parameter. It's defined as a string. It has a default value. And then this is a really great example of how you can force the certain outcomes. So you can imagine that if you did this, okay, what you're doing here is you're providing a parameter with essentially an open field. When somebody's taking this and deploying it, they could, in theory, put anything they want into the environment parameter, which probably isn't what you intended. So you can use the allowed values to limit what somebody can put in there. And I'll show you this in the console. We're gonna do this for a couple things. What this allows you to do is when you put allowed values on a parameter, it just gives you a drop down. Okay, so in this case, I can only select one of two values, production or development. You can see another example. We'll talk about these in a little more detail later on, but a lot of times we like to put conditions, we phrase them with is. You know, is this a public VPC? Is this a protected VPC or a combination of the two? And we'll talk about those in a little bit here. Okay. So let's start with something really simple. We're going to start with a security group. And when we think about this security group, I immediately know that I want to use those same, actually, why would I type that? It's just, it opens us up for typos. I want to have the same set of what's the word I'm looking for? Tags, there we go, on all of these resources. Okay, so I'm just going to cut and paste those into here. The other thing that I know I'm going to need is a security group is tied to a VPC. So I'm going to need to pass a VPC in. Now you have options here. You can do this, okay? And then I guess in theory, you could do something like this, which is then the unique identifiers for the VPCs. The challenge here is that this is hard coded, right? So you could have a bunch of these, right? Just like that. But the problem is if somebody creates a new VPC and you wanted to deploy this security group into it, now you got to monitor, or you got to modify this template. So this is a great example. Whoops, this is a great example of where we could use one of those built-in parameter types. Okay, so let's go have a quick look here at what we have for options. So if we go over to the parameter documentation, and you can see here, they're going to define, you know, there's our allowed pattern. They're going to show you all the properties that you have available to you. Descriptions, right? We're not putting descriptions in, but you might want to do that. It's a great way to, again, somebody else is going to look at this template later on, so don't make them guess at what you were thinking about, so you can put a description in, lengths, and all that kind of good stuff. We want to scroll down here to find the built-in, there we go, AWS specific parameters. And you can see that we just have a structure that we need to follow here. And we need a VPC. So there is the one that we want. This is going to, when we deploy this, give us a drop-down list of all the current VPCs. And that's all we need to do. Okay. Otherwise, without this, we're going to ask the person who's running this template, whether they're doing it manually through the console or building out something like a CI script, we're going to ask them to then type in the unique identifier for that VPC. Probably not what we want to do. Okay, so that's a pretty basic example of a simple parameter definition. Okay, remember, this is optional. The next section is a mapping section, and this is a key value pairing. Quite often, you'll see these, and we're going to do an example of this in our walkthrough here today. We simply use these for machine images, Amazon machine images, AMIs. This is why mappings are really important, because what we can do is we can say, hey, if you run this template in region 1, use this AMI. If you run it in region 2, use this AMI. Okay? Now, it can be any key value pair that you want. You can do something way more complicated than that, but quite often, that's what we use them for all the time. Okay? Once you've defined that mapping, we can use another intrinsic function. We can use a find in map intrinsic function. And that then allows us to refer back to the map that we set, its logical name, and then the key value pairs that we've set up, and essentially inject that value into the template when it's being interpreted by the CloudFormation engine. Just like parameters, this is optional. Okay. So if we go back over here, we're going to create a mapping section in our EC2 template. Now this is going to be a little like a cooking show. I'm not going to try to write these all from scratch. We only have about an hour today. So here is the mapping that I created earlier on. So let me explain this to you. This is the logical ID. Okay, so that's what we're going to refer to later on. This is my top level key. So essentially, if you're running this in US East 1, here are the two AMIs that I want you to use. If you're running it in CA Central 1, here are the two AMIs that I want you to use. In my brain, when I was writing this out, I was thinking I may have multiple EC2 resources defined in this template. One for my web servers, one for my application servers, and maybe I have different AMIs that I want to use for those. Okay, so this is a simple example of how that might work. Okay, so that's a mapping. Again, optional. Conditions are if statements. Conditions provide us with the ability to interpret a parameter value and then make a decision on how that parameter value, the setting of that parameter value, affects the deployment of resources within our template. So a really simple example of that is we want to avoid creating multiple templates. So in my example, this little three-tiered architecture that we've talked about, I'm probably going to have that in prod, and I'm probably going to have it in a development environment. I don't want two templates. Right? I want to have a single template that I could run in both of those environments in order to build out those stacks, right? That three-tiered architecture automatically for me. This is where a condition can come into play. So what I could do is I could say, you know, is development. Let me actually flip back over here because we've got an example of that here. All right. Is this VPC public? Yes or no? And then what happens is we can set the value of a condition based on whatever the value is that we're finding in a particular parameter. So we're going to set this is public to true if the is public parameter value equals yes. Is it protected? Same idea. If the is protected parameter value equals yes, then we'll set it to be yes. Okay. Now, if we scroll through this, I'll show you. Here's an example right here. Once your conditions are set, you can then use the condition property within the resource definitions to determine whether or not something needs to be deployed, or if you wanted to do something a little more complex, what's the configuration of that resource. So in this example, it's really simple. If we're not deploying a public VPC, then there's no reason to deploy an internet gateway, an IGW. Okay, so it's going to look back at what is the value from this to determine what it needs to do here. If this is true, we'll create the internet gateway. If it's false, we don't. In my earlier example about a dev environment versus a production environment, you might have a slightly different approach. You could say, in production, I want M5 instances. If you're deploying this, excuse me, if you're deploying this in development, I want burstable instances, let's say T3s. Okay. Gives you a lot of flexibility. So that's a condition, also optional. Now the resource section is really where you're going to spend the majority of your time. This is where you're actually going to deploy, or sorry, define the resources that you need for your solution and what their configuration is. An EC2 instance has to have this much disk space. It has to be this instance type. It has to use this AMI. A security group needs to allow this port in, this port out, those types of things. Okay. One of the things that's important to remember about CloudFormation in general is that once you've defined your CloudFormation template and you run it through the CloudFormation engine, CloudFormation by default will try to deploy those resources in parallel, which when you think about it makes a lot of sense, because if we had to do everything sequentially, it's going to take a long time to do that. If you want to override that default approach, though, there is an attribute that you can use, and it's called depends on. And going back to my simple example of a web server and a database, you may need that database up and running before the web server that's sitting in front of it. So what you could do is you could have in your template, you could have a definition for your database, your RDS instance, and a definition for your EC2 instance. In the EC2 instance definition, you would use the depends on attribute, okay? And you would say the EC2 instance depends on the RDS database being deployed. When CloudFormation looks at that template and it runs it through to create the stack for you, now you're controlling the order in which those resources are deployed, okay? Without the depends on attribute, though, it's going to deploy everything in parallel. Now, you know, every Tuesday, I shouldn't say every Tuesday, I've been breaking my rule a little bit, but generally on Tuesday nights, we broadcast on Twitch building out CloudFormation templates. All I do is write CloudFormation templates. It's pretty much a major part of my job. So documentation really is your friend. There is no possible way to understand what everything is when you think about all the different resources you can define and their configuration. So this is where you're going to need to basically open up the CloudFormation documentation, and you know that you're going to deploy a security group, and that security group, then you could look at the different properties, which properties are required, which properties are not, and that's going to help you build it out. You're going to do yourself a favor by referring to that documentation when building everything out. Otherwise, it's a lot more trial and error and trying to remember stuff. So the documentation is definitely your friend. And this is the one section in a CloudFormation template that's required. Everything else is optional. We'll come back to resources in a second. And then finally, the last section I wanted to talk about today are outputs. Okay? The name pretty much tells you what this is. It allows you to define values from the resources that you are creating in your template. You know, what's the logical ID assigned to the security group that I just created? What is the IP address, the private or the public IP address of the EC2 instance that you might have deployed? You can use those outputs. You can just simply put them on the CloudFormation console so you can go and look at it. I think really importantly, though, is outputs can become inputs for other templates. Remember, I was talking about this idea of a multi-template strategy where you take the entire application stack and break it down into individual components, right? An output from template one could then become an input for some other template in that stack or in that solution, okay? Really, really important. And like everything else, this is optional. Okay? So those are the main pieces that we want to talk about today. We've already mentioned the depends on attribute. That's a pretty basic one. There are a number of other resource attributes that you can define, though. And these really are all about control. You want CloudFormation to take some sort of action or use some type of, for lack of a better term, logic when it's creating the resources that you defined in the stack. Okay, so depends on, we talked about deletion policy. By default, when you run a delete stack operation, CloudFormation does exactly that. It deletes all of the resources in that stack. Okay? A deletion policy provides you with a level or layer of protection. What you can do is you can define a deletion policy that overrides that default behavior of CloudFormation. You can say, yes, I want you to delete this RDS database, but take a snapshot of it first. Okay? Or you could say, yes, I want you to delete everything in this stack, but retain the database. Okay? And this again is where something I mentioned on the last slide, the importance of the documentation. Deletion policies, essentially you can leave the default, delete it, you can retain it, you can run a snapshot, but then delete it. But depending on the resource that you're defining, that resource may or may not support all of the options. So you need to look, okay? So it's essentially a deletion policy overrides the default delete everything. Creation policy is the opposite of that, in the fact that it it allows you to work logic in to the deployment of that stack. Quite often, a creation policy is used when you're defining an auto-scaling group. Okay. What you're able to do in a creation policy is, let's say you've got an auto-scaling group defined and you say, I want a minimum of 4 machines and a maximum of 10 machines, just to make a number up. You can put logic in a creation policy that essentially tells CloudFormation to wait. Wait until you get 4 success signals back from the creation of that auto-scaling group before you do anything else. Okay. You can also put a timeout period here, because obviously if something does go wrong, you don't want to wait forever. So you could say, continue if you get 4 success signals within the next 5 minutes. If you don't receive 4 success signals in the next 5 minutes, consider that to be a failed deployment, roll back. And as is the case, these are all optional. And you would want to refer back to the documentation to understand exactly how this is all working. So let's go back to our templates, and I'm going to do some magic of a cooking show, and we're going to grab out of the other templates and just show you how this all is set up. Okay. So if I go back to my security group, we've defined the parameters already. Let's pull up our cheat sheets, and you can see I've got basically those 4 templates, and we're going to cut and paste this, and then we'll talk about it really briefly. I'll point out some of the things that we've talked about. Cut and paste. We're going to be careful here. There we go. This is a logical ID. This is how I'm going to refer to the security group in other components, right? Like I can use that intrinsic function ref. Everything that you create will have a type definition. So in this case, I'm defining an EC2 security group. And then this is really where you're going to dig in, the properties. One other thing I want to point out about the properties. We mentioned already that some are required, some are optional. Remember that I mentioned that you can perform operations on a stack? What I'm thinking about here is, let's say I want to go in later and add another rule, right? Whatever that might be. Okay. This is where CloudFormation documentation is really important again, because depending on the attributes that you are modifying in a resource definition like this security group, when you run an update operation, CloudFormation will run that update without affecting the resource. Okay, that's really what you want. You don't want it to do anything. It may have to interrupt the service, but the resource is retained. And then what you're really watching for is situations where the attribute that you've changed requires the resource to be recreated. What that means is that CloudFormation would then delete that resource and recreate it. All of this is well documented in the CloudFormation documentation. Every attribute will show you, if you change this, what happens when it runs an update. Okay. So I've got my description, my rules set out here, and then I've got my VPC. And you can see that I'm using an intrinsic function here, ref, to refer back to the VPC. The VPC, I'm using an AWS specific parameter type, gives us a drop-down list of all the VPCs that are in this account. And then I've got a bunch of other refs down here. And then I was mentioning outputs, right? Whether you just need that data on the CloudFormation console, or you want to be able to get, in this example, the security group ID by running a CLI command, a CloudFormation CLI command. Outputs are optional. We're referring here to the security group to set its value. And I mentioned that outputs can become inputs. If you want to go down that path where you are tying templates together, and in more complex scenarios, we will often do that if we know these 5 templates are used as a group to deploy that web solution. Outputs become inputs. The way that we define that is we create exports. Okay. Now I can refer to this export in another template and use it as an input. This is a good example here of how you can combine intrinsic functions with pseudo parameters. Intrinsic function of sub, pseudo parameter of stack name. Okay, so now what we're doing here is whatever I pass in as the stack name, I'll show you this here in a second, becomes part of the export name. So let's deploy this. Hopefully I haven't been logged out of my AWS account yet. Okay, looks good. You can see that I went ahead and deployed the VPC that we'll use already, and we're going to say create a new stack. Now normally we would do this all through a CI script or something like that, but this will give you an example of how this works. So we're going to use our security group. I hope I did a good cut and paste. I did not. See that? Okay, so let's do this instead. This should be the one that's working. There we go. So I'm going to call it webinar SG. So that's my stack, and remember that's what gets imported. Here are my default values, right? My drop down allowed values. I'll leave it as default. Who owns it? How do I get a hold of that owner? And then this is the AWS parameter, built-in parameter type. So I'm going to say I want to associate this security group to this VPC, and we'll run it. Okay. You always get these review screens. We're not going to worry about change sets today, and we can just deploy. Okay, so that should happen pretty quickly since it's just a single security group. There we go. Okay, we're all done. And now, since we have the outputs defined, there's our identifier, there's the value, and then if I wanted to use this as an import, I could refer to the export name later on. Okay, so that's our security group. Let's have a look now at the EC2 instance, and we'll do the same thing. Okay, we already set up our map. This has significantly more parameters, so we'll cut and paste these and we'll look at the new ones. Okay, and then we've got the actual definition here. So let's go through these two sections first. So this is what we saw before, okay, standard stuff. Here's an example of passing in an instance type and then limiting what somebody can select for the type and size. The default is a small, but you get that same drop-down list. We saw this one already for our VPC ID. Now we've got some additional ones here. Select the subnet, give us a drop-down of the subnets. Remember that in order to log in with administrative access onto this EC2 instance, you need a key pair. So this is going to show me all the key pairs that exist in the account. Again, it allows me to select, so I don't have a free form field, and then associate it to a security group. I showed you your mappings already. Here's an example of the intrinsic function find in map. We refer to the logical ID of the map, in this case AMI ID. Now we're mixing again a pseudo parameter. So what this allows us to do is I'm going to run this in CA Central, which means it's going to pick up the values from here. You could take this same template now and run it in US East 1 and it would do the same thing. And then this is the lowest level. It's saying, hey, grab the machine image, the Amazon machine image for whatever is in CA Central 1 called web. So we're going to use this one. Okay. More intrinsic functions. Nothing kind of new here. We're essentially referring back to all the parameters that we set at the beginning. And then if we grab the outputs, this will look very similar to what we've seen already as well. Right? So we're good there. Let's deploy this. I'll use my cheater one again, just so that I'm hopefully not having any sort of typos. So we'll call this webinar EC2. Our development type or our environment is set to dev. Let's make this a medium just to show how this works. First thing I know need is my key name. I've already set that. There's our owner email. There are a bunch of security groups. Now here's the one gotcha. You need to make sure that you're selecting the appropriate security group. If you select a VPC and then a security group from another VPC, it's not going to work. So I'm going to go down here and I'm going to say, I want to deploy this in webinar. And I know that it's this one, webinar security group. So we'll select that. And then the same thing goes here. I need to make sure that I'm selecting a subnet within my webinar VPC. And it doesn't really matter where I deploy it. I'm going to deploy it here. This is one of the things that I think is why exports become important as imports for another template. Normally what we would do here is we would have a series of outputs coming from the VPC template, and we wouldn't actually even set these, because we would say, okay, when you're deploying the EC2 instance, refer back to the exports that came from the VPC. I need its VPC ID, I need its subnet ID, I need all these things, and that populates it. This is still nice though, because you may have a situation where a user doesn't have a CI deployment. This still helps them be more successful by avoiding having to have somebody type in these long numbers, right? The unique identifiers. So hopefully I've selected all that right. We can say next. Just to show what I mentioned before, it's actually not what I want. I want this here. There's our rollback on enable feature. Rollback on failure feature, and it's enabled by default. If I was running this for the very first time and just wanted to maybe stop it from rolling back to simplify some of my troubleshooting, then yeah, I could disable that, but I'm going to leave it as enabled. Okay. The common review screen, and then create stack. So we'll let this go. This might take a little bit longer, and we'll have a look at a few remaining slides. So we've gone through the basic components of a template. Okay. Now there are some other things that we haven't talked about today, keeping this high level. All of these are optional. So there's a metadata section. The metadata section just allows us to add additional information about what's in the template, right? So you could then go in and say, hey, you know what? This is a template that deploys a number of EC2 instances. Those EC2 instances are used for the corporate website, something like that. In addition to that, though, it allows you to do a bunch of other things. So we were in the console, and we just had a list of the parameters that we could set. Inside the metadata section, we can also modify the CloudFormation console. So I could logically group things. I could say, okay, this is all for EC2, this is all for VPC. I could relabel those drop downs to say, you know, subnet ID rather than just the parameter value. I could put text under it to make sure that the person that's running this knows what we're expecting. So you can get really advanced here. And you can also bootstrap an EC2 instance. What's that mean? CloudFormation would allow you to execute a script, for lack of a better term, on that EC2 instance when it's coming to life. So this is what they refer to as bootstrapping. Start that EC2 instance up and run XYZ on it as it's coming to life. Okay? So you can do a lot of stuff with metadata. When we're building out templates that we're delivering to customers, we would very much use the section of the metadata that allows us to control the CloudFormation console. Because although we're going to deploy with CI, we don't know what that customer may do later. So we want it to be easily understood when they're trying to run something after. Okay. There's a rules section that allows you to exactly define what it says here, create rules that validate the parameters that are being passed in. This is what I, again, think about when, how can I increase the likelihood of somebody other than myself successfully deploying this template? You have a transform section that allows you to define macros, and those macros will be used against the template when it's being processed by CloudFormation. Metadata, rules, and transform are all optional. Okay. We'll wrap up here with just a couple basic strategies for building out these templates. I gave you the very first thing I would suggest that you do when testing this out. Create your first template that is an AWS budget that would notify you if you go over a certain number. No sense in being surprised at the end of the month. I also mentioned a couple times, my suggestion is to create small templates. They're easier to manage, they're easier to troubleshoot. You also have to think about, you know, you probably don't want to be the keeper of that template until the end of time. Oh, excuse me, Alexa, stop. Telling me I got to be somewhere. So you don't want to be the keeper of that template forever. If I create a small template, I could give it to another person on my team, a customer, and with a little bit of explanation, they could start maintaining that template immediately. If I gave them a 1,500 line template, that is a much more challenging task. So create small templates. They're easier to manage. They're easier to transfer to other people. They're easier to troubleshoot. Okay. The caveat with this is, now remember, you have to think about outputs becoming inputs. How are you going to handle that? I'm hoping that you can see even our basic templates, how many intrinsic functions, how many pseudo parameters that we used throughout those two really simple security group and EC2 definitions. Make sure you use both of these, okay? Again, going back to kind of the common theme here, flexibility, portability, okay? Without intrinsic functions and pseudo parameters, you're going to have a lot of maintenance work to do on these templates as you use them in different environments. And today we use the CloudFormation console to deploy this. Really simple to do that. In real life though, my suggestion would be to always automate your deployments. We do this every Tuesday night, simple automation with GitLab CI scripts that allow us to run CloudFormation deploy commands, other support commands that we need when we check this code in. It's a, you know, if I'm building a template for the first time, I often do what we did during this demo, where I just kind of build it out, I throw it into the console and see what happens. But once it runs that first time successfully, then we'll often just throw it right into a simple CI script so that every time something's changing, it deploys. You know, I should have had tip number 4 in here, just thinking about it now. My fourth tip here would be to use change sets. It's a little bit more of a complex topic, but a change set is effectively a dry run. And remember when I mentioned that depending on the attributes that are defined in your templates, when you're running an update stack operation, you may or may not have to replace a resource depending on the attribute you've changed. What's great about a change set is that it will tell you what would happen if you were to actually run the update. So that's why I call it a dry run. If you're going to change this resource, is it going to be replaced? Yes, no, or maybe. Okay. Yes and no is pretty self-explanatory. Maybe you have to dig into a little more. So tip number 4 is when you automate your deployments, always deploy with change sets. Validate those change sets, are doing what you expect them to do, and then deploy them. Okay? So that's it for the day, folks. Thank you very much. Let's go back here and have a look. What happened? There we go. Our EC2 instance is deployed. If we go over to the console here, there is the EC2 instance up and running. And you can see it's a T3A medium. We overrode the default. If we jump back over, oh, sorry, I closed it. Let's go back to CloudFormation for 1 sec. And we go to the Outputs tab. You can see now we've got the private IP address. This was what I included in the Outputs section. We've got the unique identifier for the instance, and we've set export names so we could use those now as imports in a future template if that made sense. Okay? So thank you very much. I appreciate stopping by today, learning about this. We are working on a much more in-depth course. I'm hoping that by the end of August, maybe into the beginning of September, it's ready to go. I'll let everybody know about that as we get going. We're going to offer some discounts to our friends to give us some early feedback on it. So thanks very much, folks. Enjoy the rest of your day, and stay safe out there. We'll see everybody later. Thanks, Kevin. I appreciate it. Talk to you later, guys. Bye-bye.